Ouais, ça y est, c'est parti là. Là, c'est parti. Moi, je vais vérifier. Il y a une latence de 30 secondes. Et donc maintenant, là, tu prépares plus ton zoom avec ton. Et là, tu
Bon, okay, so my presentation will be on proactive model for open domain conversational search. So supervised by Laurent Soulier. It's not working. Okay. Okay. So something we all do every day is web browsing. So it usually involves a user searching for information and a system retrieving documents that matches users' need, usually from large collections of documents. And the information retrieval community has continuously improved the system by proposing better query document matching algorithm, or by better utilizing browsing history, or by scaling these models to very large collection of documents. All these improvements were to improve the user experience by inherently reducing the time, but also the cognitive load of the user. However, the search paradigm has not evolved significantly in the last 30 years, so it mainly consists in a few keywords entered into a search bar with results presented as a ranked list of relevant of documents, as here. And in the case where a relevant document doesn't match the user's information need, the user needs to reformulate its query. So rating the progress in deep learning and natural language processing led to better language models that are pre-trained on very large corpus, and that can compute very good word representation, and that have demonstrated very strong performances on a very wide variety of NLP tasks, such as translation, questioning, summarization, and conversation, and allow for more natural interaction with machines. So today, these conversational systems, these models can be used as conversational systems to access information. For example, if we take a conversationally deployed model such as Bard or ChatGPT, given query, the query is contextualized by the conversations, and they usually are trained to answer very long and well-structured answers, such as an example like this. However, they may lack factuality and truthfulness in the answer, and the answer is always these models are trained in a very reactive way. This means that the paradigm is always the user asks and the system answers. So these models are difficult to align with user's need. So ideally, we want models that are able to engage in the conversation with user to better understand the user's need. So, as I mentioned, beyond providing answers and answer, conversation search systems need to be proactive in the conversation. So they can be useful to answer factual questions, but also to perform exploratory search and help the user navigate virtually through documents. And the system can also take the initiative in the conversation to ask user about its information and refine its query. And the system also utilize the conversation to retrieve documents and the retrieve document to enrich the conversation. So there are existing conversational information seeking systems in the literature. So for example, conversational questions, these are systems that basically answer factual questions in open domain, and they are trained under the paradigm of the user asks for something and the system answers. But there are also conversational recommendation, the goal for the system is to retrieve a set of relevant documents, and the system this time asks to the user about features or attributes like the price range or the color, and the user answers. So for the big picture of proactive conversation search system, these are systems that are able to interact with both users but also systems. For example, search engine or various APIs to retrieve information and documents that better match the user, But they can also interact with the user by, for example, asking clarifying questions to better to provide more accurate answer in the end. So the main challenges is to, as I said, provide accurate answer. This means that the answer must be specific to the user need, but also need to be faithful and factual regarding the retrieval of documents. So understanding the user need first is still a challenge today in information retrieval because queries are often short and ambiguous. They can be influenced by the word selection for the queries can be influenced by the knowledge or the context of the user. Sometimes when the user don't have a specific or clear idea of a topic, for example, it's exploratory search. And also a user can have various expectations. So for example, given two users having different information need, one wants a Spanish traduction of the flower of the dead, and the other wants the name of the flower of the dead in Spanish. So they enter the same query, but they expect a different answer. So understanding the user need in the literature, there are various methods, such as query suggestion, where basically the system suggests a list of queries or recommendation to user, and the user can either interact by selecting a better or more relevant query. There's also a personalized search where the system adapts the ranking, the retrieved documents to the users, based, for example, on the browsing history of the user, but also on additional information such as locations and so on. And lastly, one other method is to involve the user directly in the refinement process by asking clarifying questions. So clarifying questions are questions that the system asks the user to better identify the topics or the information needed to avoid confusion or misunderstanding. And it will also help the system to narrow down the search space. So for example, here given the query, I have a problem with my laptop, it freezes when I turn my mouse, and search it would exist. A possible clarifying question from the system could be, what OS are you using? Or is your mouse connected via Bluetooth or USB? And other types of clarifying questions. So it helps the system to generate answers that are more specific and also narrow down the search space. However, there are risks with asking clarifying questions. When the questions are low quality or when too many questions are asked, it can really deteriorate the user experience. So in the literature, there are various methods proposed to ask clarifying questions. So like ranking methods, where here we have a pool of pre-existing clarifying questions, and given the query, for example, we predict there is a system that predicts a score, a relevance score between the query and the clarifying question. So, for example, given a click, a probable clarifying question could be, do you want biography? There are similar approaches, but with facets, where given the query facet and the pool of, given the query iron and the pool of facet, a probable facet could be thrown, and then this method uses templates to construct the clarifying question. So in this case, are you looking for iron thrown? And there are also methods to improve the naturalness of the generation. So like by using a language model that is where the generation is facet driven. This means that given a query and a facet, the model wants to generate a clarifying question according to clarifying question. So the second challenge was about generating faithful and factual answers. So in the literature, there are various methods to help a model to generate more like faithful answers. So one is to language models have demonstrated strong performances in various tasks such as natural language processing and so on. And scaling these models allow them to increase their ability to restore information accurately. However, even the largest models today are prone to inaccuracies in answers, and which are called hallucinations. And so to deal with this problem, a common method to reduce hallucination is to ground the language model to documents that are previously retrieved. So, for example, given for the retrieval augmented generation, given a user question, first a set of documents are retrieved, and then documents and questions are used. So the retrieved documents are used as additional context to generate an answer. However, this method by design relies automatically on the external database for each entry without considering the inherent ability of the model to answer to the question. Other method, so what I call active, because here the method are used to teach language model to use external tools depending on the user input. So it can be either a search engine, external memory, calculator, or so on. So there are various models proposed. First, the lambda and blender plots, where basically the model learns to generate, to code the proper API given the entry. So for a question, it generates a search token, which allow the model to call the search engine. For models such as WebGPT, they are trained to interact directly with the search engine. So they are given the ability to query or quote or through link and scroll pages before answering. And lastly, there are models such as Toolformer, where author automatically annotated the training data with code if it expects to lower the perplexity of the answer. This proposed method does not account for the ability of the language model to answer directly to questions. So, for example, the model Toolformer told the API 99% of the time, even though this model are very capable of answering probably a portion of this model of these questions without relying on an external database. For the challenges faced with conversational search systems is the lack of supervision. So what I mean is that interacting with real user is time-consuming and costly. So it's really difficult to scale this dataset to a large number of examples. So usually you can see here when the datasets like FULAC or Clark contain the user answer and are multi-turn or annotated example, they don't scale much. Yeah, and when the dataset scale, they don't have annotated document or something. So in other domains, that deal with interacting with users, such as recommendation or collaborative conversational search system, a conversational system, they usually rely on synthetic data. So basically what they do is that they mimic the user's behavior at each turn in the conversation. But when I started my thesis, basically the commonly used user simulation were agenda-based user simulation, where they use specific features or attributes in the constraint, for example. But in information retrieval, we don't have annotated user intents within the higher datasets. So it's much more difficult to manage. So in this thesis, we are interested in three research questions. So the first one is, can we leverage user simulation to build multi-turn query clarification from ad hoc IR dataset? The second one is, can we build large-scale synthetic conversational IR datasets, so at minimal cost by utilizing user simulation. And lastly, we want to balance the knowledge of the language model and also the API calls. So can we reduce the dependency to search engine of this model? So in the first work, the objective is to refine the user query using multiple query suggestions. So we have a system that at multiple times, that interact with the user multiple times. And in the end, after T interaction, we want to retrieve more relevant documents. And we want to demonstrate that increasing the number of interactions with the user is beneficial. And in this work, we simulate the user solely by using what we call a classical IR dataset, which contains query and document relevant judgment. And the constraint is that we have no prior information on the users, and that we use only classical IR dataset. So for the method, the hypothesis is that we can always find a reformulation, so a query that is more optimal than the original user query. So what we did is that we consider the IR agent, and we so the IR agent is divided into a generation process. So first, given the user query, we generate a large set of queries. And then we have a selection mechanism that selects a number of queries to suggest to the user. And then the user simulation gives a feedback to queries, suggested queries. And given the feedback, we can then re-rank the queries by performance prediction. And we repeat the process over the turn of interaction. So we use for this the MS Marco passages 2020 dataset, which contain 8 million passages. And we measured the mean reciprocal growth and the mean average precision, which are commonly used information retrieval metrics. And the goal was to evaluate the impact of the multi-turn query clarification. And we compared ourselves against the user query and also an Oracle model that always select the best reformulation from the generated pool of queries. We also compared ourselves against Monotype, which was the state-of-the-art model at re-ranking passages and queries passages at the time. And we implemented various strategies along with our model. For the result, ranking queries by performance prediction is really a difficult task if we only consider the original user query. So for example, because there's a lack of context, if we look at the notified model, for example, our model is very dependent of the selection mechanism. So we can see that the random sampling model, which basically sample queries, two queries from the pool at each turn, doesn't have a very consistent performance. And we are still far from the best we are still far from the Oracle model. So in previous work, we proposed a multi-turn query refinement framework, and we utilized user simulation to mimic user system interaction. The main limitations is that interaction are built solely on the first query entered by the user, and that our model is very heuristic, is follow a heuristic selection policy. And also the user simulation in the experiment was greedy. This means that given an interaction, it always selects the best given formulation. And the goal after that was to improve the existing model. to perform both the generation and the selection process at the same time between each interaction. So we regenerate a new set of queries between the interaction with users. So we use a GPT-2 model that was fine-tuned to complete a set of queries. So given the previous queries chosen by the user, the model learns to complete the set of queries. And we also improve the generation using reinforcement learning to improve the diversity of retrieved ranking of retrieved documents. And this time the user simulation is epsilon greedy. This means that it has a probability to not select the best queries at the suggestion during the suggestion. So the result, we compared ourselves against Google suggestion. So on the right heat map, we can see that with the Google suggestion with the number of interactions with users, and also with the epsilon parameter of the user simulation. So 0 means that the user simulation is fully cooperative, and we can see that so Google suggestion have very strong performances when the user simulation is fully cooperative. But the performance deteriorates rapidly when the user is not fully cooperative. Whereas our model is a bit more robust in these settings. To conclude, we rely on these works on user simulation to refine user query through multiple interactions. And we perform all of our experiments on adult higher datasets that only contain the query and document relevant judgment. The main limitations are that interaction with user are very simple and only consisted of few query suggestions. And we do not consider other parameters of the user simulation, such as patience, engagement, or cognitive load. So after this first work, what we wanted to do is to still rely on higher dataset, and we wanted this time to augment this dataset in order to train conversational higher dataset model. Sorry. So to give a little bit of context, higher datasets are composed of query and also of documents. So documents in the collection are annotated as relevant given the query or irrelevant, and the large majority of the documents are not even annotated. And we wanted to keep this relevant judgment on documents and queries, but to augment the dataset with additional system and user interaction. So in this case, clarifying questions and user answer. And for this, we propose first an offline generation framework, and then an online inference framework. In the offline generation framework, the goal is to generate clarifying questions, but also utilize the relevant judgments on document to predict what the user would answer. And the online inference, this time we don't have the relevant judgments of documents is unknown, and the questions, the clarifying questions are asked about retrieved documents. And we use a trained user simulation to answer automatically to clarify questions. So for generating clarifying questions, what we did is that we rely on the model proposed by Sequoia, which is basically one language model that was trained on the Pure dataset, which contains about 2,000 presets of query facet of clarifying questions. So given a query and a facet, there's a label of clarifying question. The main downside is that we can only generate yes or no questions that are about only one facet. So for the offline generation, given a query and irrelevant documents and annotated relevant documents, what we did is that we extracted keywords from these documents, and these are our facets. And we use these facets to then generate what we call negative clarifying questions and positive clarifying questions, which are respectively a question that comes from irrelevant documents and relevant documents. And then we make the hypothesis that a user will answer no for negative clarifying questions and positively to positive clarifying questions. So yes, in this framework, we use the information on the relevance of the. For the online generation this time, we don't have relevant judgments of documents. So what we do is that we use the user query to retrieve first documents, and then we extract keywords from the top retrieved document to generate the clarifying questions. And then we also use a user simulation to automatically answer to these clarifying questions. For the experiment, we use MS Markov passage 2020. And for the passage extraction, we rely on the mini-LM model, which basically computes the similarity between words and between passage and word within this passage, and select the most similar. And for generating clarifying question, we use the T5 model. So we evaluated the quality of interaction generated offline using automatic metric on the ClarkQ dataset, but also using human judgment on the MS Markov, so on the generated clarifying question of MS Markov. And lastly, we wanted to see if these synthetic data were actually useful for an higher task. So we considered a ranking task, and we trained a ranking model with this additionally with the augmented data. So for the evaluation, on the automatic on the ClarkQ, with automatic metric, we consider the template and also the language model without the facet and with the facets. And we can see that the facet really helps reconstruction clarifying questions. We also compared the generated clarifying questions with their provenance passages. So the positive and negative accordingly. We can see that the similarity is higher for the positive clarifying question with the positive passage. We also use human judgment on the generative clarifying question on the clarifying question generated in MS Markov. So we measured naturalness, usefulness, and relevance. Even though our model does not generate the most natural clarifying question, they are by far the most more useful and more relevant. We also compared the automatic answer generation with what a human would answer, and we obtained an accuracy of 0.68. So for the higher task now, we wanted to see again if the synthetic data was actually useful on the higher task. So we compared ourselves against Model 5, so which is a model that reruns documents given the query and documents. So it estimates the similarity score. And our model is basically the same, but it also has access to the clarifying question and the user answer. And we can see that the synthetic data generated, so the clarifying question and the answer associated, allow to retrieve more relevant documents. So we also wanted to extend our framework to multi-turn. So what happens if we have multiple interaction with user? So given a query, a clarifying question, an answer, and then for next turn, clarifying question and an answer, and so on. So we computed the score of documents as the sum of the log probability of documents being relevant given for the interaction. What we obtained is that also the baseline shows the similarity between document ranking between turns with user. And below we can see that the table which shows the increasing number of interaction with user. this shows that synthetic data allow to provide more information about relevant documents and increasing the number of interaction with user is actually useful. So the main limitations here is that clarifying questions are really simple. They are single facets, and the quality of this clarifying question really depends on the keyword extraction. Sometimes some keywords are extracted from document but are not really relevant. The user simulation is really simple. It's only yes or no. We do not consider cooperation or patience or other parameters. And also, we do not detect the need for clarifying questions. This means that we, at each turn, ask for new clarifying questions until the user. So we wanted to provide a new dataset, so new supervision to generate more complex clarifying questions that allow the system to detect the actual need of clarifying the query. So, for example, on the right, for a non-ambiguous question, song I love rock and roll original is only one possible answer, which is arrows. And on the right, for ambiguous questions, who plays Scarecrow and Batman? So there are multiple movies with Scarecrow and various possible answers depending on the actor. So possible clarifying question could be, which Batman movie are you referring to? So for this, we consider the NQ dataset. So it's a dataset it's a subset of natural question that was relayed by Protus annotators or Protus workers. And the authors found that 50% of the questions in natural question are actually ambiguous, which means that they have multiple possible answers depending on the interpretation. For example, for the question, what season does Mary and Derek get married with Grey's Anatomy? So informally, they get married in season 5, and legally, they get married in season 7. So the dataset contains non-ambiguous but also ambiguous questions, and with annotated Wikipedia provenance. And the task given with the dataset was to retrieve all possible answers given the question. So here, our objective is to utilize this dataset to generate high-quality clarifying questions that are more natural and not facet-driven, and that are supported by a collection of documents. In this case, this is Wikipedia. So what we did is that we use GPT-3 in future learning. So we show examples of clarifying questions we wanted to generate using a well-crafted example. And so, for example, for the input question, when did the first generation Kindle file come out? There are multiple possible answers associated, depending on the region. So in the US, in Europe, in Japan, and GPT-3 generated which region are you interested in for the first generation Kindle file release date. And to evaluate this dataset, we selected questions from generated questions, and we use human judgment to evaluate both naturalness and relevance. Relevance meaning, does the clarifying question cover all possible answers, or does it select? Is it revolving around only a few? So there are more qualitative examples here, and we basically the human evaluation showed that 81% of the generated questions are fully relevant, which means that they cover all the intents. So, for example, for the second row, do you want to know about 2010, 2000, and 1990 of all time on are you interested in consecutive rules? You can see that all the 5 possible answers are contained in the clarifying questions. And also, 94% of the generated questions were considered as natural. In conclusion, in this both work, we augmented ad hoc IR dataset with synthetic interaction between systems and the user. We evaluated our generated dataset using human evaluations, and additionally, we we provided a better supervision to generate more diverse and more natural fine questions. These are promising results for the use of synthetic data for conversational AI. However, the main problem with this approach is that the user simulations are not realistic. They are basically consisted of yes or no answer. So lastly, previously we saw interaction between user and system. So system to user to better understand the user's need. In this last work, we are interested in system-to-system interactions. So to give a little bit of context, so we saw earlier that tool-augmented methods do not consider large language model knowledge. So basically, the model is trained to call external search engine for each new question. And calling search engines or relying on an external database actually induces additional time and complexity, computational cost. So the optimal strategy would be to have like an LLM that can call an external database only when it's unsure about the answer. So if the LLM is a high probability of hallucination, then it should rely on an external database. So state-of-the-art method usually rely on rejection summaries, where the model first makes the predictions to generate an answer, and then the second system evaluates whether or not the prediction is a correct or incorrect answer. Here we wanted to see if a language model was able to self-estimate its own ability to answer correctly to the questions or incorrectly before the generation process starts. So before generating the answer. So the goal here is to balance the LLM knowledge and the search engine. So let's consider a language model that can perform question answering. So it can either generate a correct answer or a wrong answer. Ideally, we want the model to generate only correct answer, but because of the training data and the language model can reach only the maximum performance on this task. So here the goal is to find a new set of parameters that allow the model to also call an external API, so the search engine, but only when it's more likely to produce a wrong answer. So basically, calling an external search engine also induces a cost as well as providing a wrong answer. So for the method, basically we learn a filtering function where we want to leave a correct answer unchanged, and we only want to mask wrong answers with a search token. So the first step is to teach the language model to perform question answering. So given the data set, we fine-tune the language model to answer questions. So once the model is trained, we use the new questions, new set of questions, and we see the language model is able to answer these questions. So it can either generate correct answer or wrong answer. Correct answer are left unchanged, and wrong answer are masked with a mask token. And these are the new lab that we want to use to retrain our model on the new set of questions. So we want to adapt the language model to predict search token instead of answering a wrong answer. So we tested conducted the experiment on a natural question trivia tree, which are two question answering datasets, and we tested on the T5 large and T5 XXL, and we compared ourselves against perplexity threshold, but also against instruction-based models. So these are models that are given a prompt and an instruction to perform a given task, and also against few-shot method. For the metrics, we measure the rate of correct answer, but also the ratio of search and wrong answer. And we also measured an F1 score that basically tells if we were able to match correctly only the wrong answer, but leave the correct answer unchanged. So what we can see here is that our model has competitive results against exogenous baselines, such as the perplexity threshold here. That in context learning and instruction models show very poor performance on this task. And if we look at, for example, T5 large and natural questions, when the model was generating correct answer, it now still generates the correct answer directly on 78% of the time. When it was generating a wrong answer, it is now masked in 77% of the time, and it only calls the API 62% of the time. So we wanted also to see various scenarios. So what's the probability of generating correct answer after searching through a database? So on the worst scenario, we have, for example, the probability is 0. So every time the model search online, it returns a wrong answer. And the best scenario is every time it's 1. So every time the model search online, it retrieves a correct answer. And we can see that for the best scenario, we have a model that is able to answer correctly in 83% of the time, while utilizing the search engine only 62% of the time. In conclusion, we show in this work, in this preliminary work, that LLMs can mostly self-estimate their ability to answer questions, some questions. And we have comparable results with the perplexity threshold baseline. However, in this work, our labeling method was a little bit noisy. In conclusion, so in this thesis, we propose to use user simulation and higher strategy framework in the open domain to evaluate models on multiple interaction, over multiple interaction. And we also propose a methodology to augment existing higher datasets with synthetic interactions to better train conversational higher models. And we also proposed new supervision to generate more relevant clarifying questions, more diverse clarifying. So, and we also showed promising results on balancing LLM's knowledge and search engine code. All this is a promising result for the use of synthetic data for proactive models. However, in this work, we have to consider a single query disaggregation. So the user has only one information need for each search session, which is not really the case in reality. And our user simulation were not really realistic. If we step back a bit and look at the rest of the field, so today conversational information access is everywhere, so in various domains such as health, customer service, online shopping, and so on. And large companies, search companies such as Google, Microsoft, and so on, are racing to integrate their language model, so their conversational model on top of their search engines. However, these models still are not proactive. They are trained solely on the sequences of instruction and answer tasks. So on reactive tasks, which are typically sequences of instruction and answer. And so they cannot drive any conversation. And they should be evaluated in their ability to engage with users and interact also with other tools like search engines. And for the short-term perspective, I really believe that the use of synthetic data for improving search-oriented conversational models is the way to go. For example, by using instruction models to generate more natural conversations. But also to evaluate this model, we need to to have benchmarks such as the TrackCast and the ICAT dataset. Also, if we consider these models as agents, so that are able to take sequences of actions, we need to have standardized evaluation environments and also more realistic and diverse user simulation. So now for the proactivity beyond search, so this thesis we were focusing on search, on information retrieval, but this paradigm can be applied on other domains. So currently the generative paradigm is that the user asks for something and the system answers or generates. So for example, for image generation, the user has a prompt, so draw me a flamingo near a swimming pool, and the system generates something, an answer, and then the human evaluates the answer and then has to reformulate its prompt. So, however, like queries in information retrieval, the prompts are ambiguous and systems are really sensitive to prompts. So it makes algorithms such as the LLM or DPO limited to fully adapt to users' needs. So the proactive system can be used to adapt answers to user specificities on the fly and help them also refine their prompt. So for example, with image generation, as we saw earlier, a possible question could be, do you want a real or inflatable flamingo before generating an image, because the first prompt is ambiguous, or for text generation, summarize these technical documents. A possible question could be for what audience is the summary, because you want to adapt the summary to various audiences. So this is the end of the presentation. Thank you for listening.
Merci pour cette présentation. Super présentation dans l'ensemble. Bon, alors, on va commencer par passer la parole au rapporteur, en commençant par Linda Tamine Lecheli, qui est professeure à l'Université de Toulouse.
Merci. Well, thank you very much for this very nice presentation. Very well done. I give some informative overview of the contribution. Very well done. And in the context of the very recent review, you designed a very nice illustration, very relevant, to highlight the key issues you tackled and the specificities of your contributions. So really, I really appreciate your presentation. Presentation was quite significantly different from your manuscript and what it was expected in a PhD presentation. So thanks a lot for that. Regarding your report, I really enjoyed reading your report for several reasons. One of the most important reasons that you deals with a very hot topic, the hype today level, and a very attractive topic, large language model for information retrieval. And it's the first thesis, PhD thesis I reviewed so far. I guess it's one of the early theses in the manual, and you should be proud of that, I think. You have the great merit to take in hand this revolution of and then to explore diverse ideas, experiment with data released recently, provide and design a new dataset, new resources for the AI community, and design some series of contributions that will different aspects of LLM information, even more particularly in conversation information retrieval. Of course, I would like to say I think that you were so enthusiastic in this subject that you talked several things. Maybe I would have liked you to deepen some experiments, more analysis regarding some key issues, to learn more, to have clearer takeaway messages. Okay. Never mind, because you couldn't cover all the issues that here in this new subject, leaving all the secrets behind LLM today. So it's an opportunity today to ask you some questions, to explore something that I didn't address in my report. So I'll just discussion and sharing of thought with thought based on your experience in this project. So my first comments about your first contribution using the simulated framework of query retrieval. I would like to discuss with you some proposed extension based on your experiments. But first, I have a couple of questions. The first question is about the user's feedback. Did you ever evaluate the reliability of the feedback proposed by the simulated user? By measuring, for instance, metrics between terms that receive positive versus negative feedback?
No, we didn't do that. But in this case, the feedback is really straightforward in the sense that I didn't talk about the information needs of the user, but basically we use the relevant documents annotated given the query for the query as the information need, and the interaction consisted of we suggest a set of queries to the user simulation, and it compares the similarity between the information need and the proposed queries and select the best.
Okay, and what were your main observations regarding this? Did you ever evaluate, compare?
No, we did not compare them. No.
And did you ever investigate in which extent generated query with feedback and context outperform, for example, expanded query are relying on traditional query expansion technique, just to see whether LLM provides some insightful or complementary or different information? Did you explore that or not?
No, here the goal was just to, we were focusing on the interaction, so not on the generation process. We only considered a reformulation model that generates a set of new queries, but we could have used other methods to generate the set of queries. For example, we could have used the Google suggestion, but it was not the main points of the paper.
Okay. And in general, based on all the experiments you did, do you think that your proposed strategy can efficiently learn from fewer rounds of feedback on that? Fewer terms. It means, did you evaluate the scenario where you have several terms, less terms, and so on?
Oh, okay. Yeah, that's the main limits of this work is that we measured for each new term the gain in relevance we measured, so here's the MRR metrics, and we measured, so okay, if we do one more term, how much does it increase? And we basically did that for n terms, but we did not simulate the user engagement in the clarification process. So,
and how do you have any idea how to do?
There are existing works around this. So one method is to, for example, have a probability that the user stop the clarification process. So given, for example, patient's parameters, the user simulation is going to engage more or less terms in the clarification.
Turn it as a prediction or?
Sorry?
You turn the problem into a prediction problem of going away or stopping the conversation? That what do you mean? What do you mean by using patient?
Okay. I mean, in the user simulation, here we don't have any parameters modeling the user's patients, in a sense that some patients may want to have multiple terms, like 5 terms with the machine before having documents, and other maybe less patient. So they don't want to interact with the machine. And some other work do have modelizations on that. So the user simulation is going to interact less or more with the system.
Okay.
But yes, not in this work.
You want to do that? Okay. Regarding the methodology proposed for the Cairo collection extension to incorporate synchronicity, I have several questions. I'm wondering if you have an idea of the strength of your hypothesis related to the mapping between relevant or top retrieved document with faces, query faces, let's see. So did you analyze, for example, whether flop document could help as hard positive for training, for example, rather than positive? Are the relevant documents so diverse?
Sorry, I can't hear.
I don't like taking the name.
Okay, no problem.
I'm wondering if you really analyze the mapping between your documentary and query faces per se.
Okay, extracted.
So really extracted query faces. For example, relevant documents, they deal really, they do all the diverse faces of the query, really or not. To take them as proxy for query faces, to the strength of the hypothesis.
That's the hypothesis we made because we in the experiments. So it's not the case for very long documents because long documents can be around a single topic but can have multiple facets in the same document. So the query, the keyword extraction would extract facets, keywords from many different facets. But in this experiment, we were dealing with very small passages. So it was more likely to contain a single facet, a query facet.
But what is the sense of this hypothesis? Does this impact the evaluation or not? Did you explore how much between the level of mapping between?
Yeah, experimentally we explored that this method of extracting keywords from documents to generate clarifying questions really impact the quality of generating clarifying questions. But we did not explore much. There's an existing work that from Ivan Sekulik that tested different methods to extract the keyword that help reconstructing better clarifying questions. But we did not explore that.
Okay, and in your opinion, how would your model in the multi-term initiative scenario? So in your opinion, how could you model the transition between one phase to another in a conversational research? Do you expect this in a fluent conversation?
So realistically,
yes.
Yeah, in the conversation, a user can during the multi-turn conversation.
There are work that target the idea of turning from phase to another. Will your model be extensible to those scenarios or not? If it's the case, how could it?
No, it's difficult with this method because we consider, for given a query, higher data set as relevant, document annotated, but for example, in MS Marco, it's really sparse annotation, so usually it's one passage is annotated for one query. So this means one information is given the query, and there was no possibility to model in the conversation multiple. But not
Okay, and do you think that your model is flexible toward this new design of conversation? Because it could be the case in a fluent conversation to move from topic to another.
It's more likely.
It's more like a naturalistic,
that's the main drawback of that work. It was in the end is that we only consider one information in,
Yes,
of the user that
one method.
we want to understand that. However, yeah, in the reality, the user may go from one topic to another. Or, yeah.
Okay, and in the case of ambiguous query, I found the human evaluation very constrained by your design choice. I found that in my view, for example, letting user identifying query phases based on top passages, and assessing relevant based only on the mapping between a question and facet, regardless of top ranked document. What did you constrain? Why did you constrain the human assessment about the relevant topic? Just only based on the query passages used for generation.
So for the online inference?
For the human evaluation in the case of ambiguous query.
For the ambiguous query, so
yes,
the
for the ambiguous
second
query,
work?
for the third, for the second one, for the second contribution.
Okay. So when we
did your human evaluation.
Yeah, on the
automatic evaluation, so it was a good initiative.
On
but you constrained the human assessment about relevance based only on the passages you used for the generation.
Yes.
I think this could introduce some bias in experiments. Are you aware which bias, for example, would this introduce? How could you improve your design choice for human evaluation, for example, in the future?
Okay, well, we did that because we wanted to not only measure the relevance of the, we wanted to measure if the clarifying questions reflect the passages that was used to construct the clarifying question. So,
but in reality, I would have like a human assessment, okay, about the facet of the query, regardless of the passages used for the query generation, no, and then try to evaluate the mapping afterwards.
Okay, I see.
I think it would introduce some bias in the results. I would like to have your opinion about which kind of bias, what are the trains that remain stable in a way. About the conclusion you made.
So experiment. We evaluated both if the clarifying question was useful given the query,
yes.
And also if the clarifying question is representing the original passage. So, and we performed this randomly on what we call the irrelevant. Irrelevant passage,
yes.
but also relevant passage. We did on both.
Okay.
So
maybe you said that could reveal some observation that could remain the same even you didn't constrain the human evaluation to the documents. Okay, I guess that maybe. And in your last contribution, you answer research question number 3. I really liked your contribution. My first quick question is about this binary view of correct wrong.
Yeah.
Because the data set is okay with the yes/no question now, correct, not correct.
Question 3.
Yes, binary, just correct, not correct, correct or wrong.
Yeah.
Okay, how could you extend this idea of not really correct, not really, because generation introduces a lot of measures about fluency, about correctness, faithfulness, and so on. So we have not a binary value.
Because
how could you extend this to this tool, this contribution to general queries?
Okay.
Not yes/no queries, correct, wrong queries. Yes.
Experiments. So basically in the literature, when we want to evaluate the ability of the model to restitute knowledge, we use question answering datasets, which are composed of questions and annotated answers. So that's what we did here, but I think you are mentioning about more verbose
yes.
answers.
Yes. Or only some part will be correct, correct but not truthful, and so on. Just a degree of correctness that we can estimate using different way.
Yeah, I think we can evaluate. So, for example, if retrieving, okay. So the goal is to compare if the model generates its answer without additional documents, and we want to compare that answer with the answer with support documents. If we have the ground truth behind this, the documents, for example, that contains the answer and that are annotated as relevant, I think we can, for example, use an NLI model to estimate a score that basically tells if the information contained in the generated answer is matching what is in the document. Because actually in the question answering, the metric is exact match.
Exact match.
So that's a problem because, for example, if my question is what is the capital of France, I can answer Paris. I can answer, oh, it's Paris. I can answer. So there's a variability in the way I can phrase my answer, and this is really difficult to evaluate. So there are methods in the literature now to deal with this. Yeah, I think, for example, an NLP model that is trained to evaluate if two statements are saying the same thing or different thing,
okay,
could be a good proxy to.
About the extensibility of your design, your model design regarding the non-binary relevance. Okay, my final question is, I guess the ultimate goal is to teach the model to be more confident and hallucinate less without relying on search. So how would you extend the current model toward this objective? Means here, there's a feeling to be wrong, okay, we'll call for search, okay?
Yeah.
But how could we learn from each other from search and hallucinate to make the model, the final model, hallucinating less and be more confident? There's some learning between the two modules of generation and call for search that will be designed in order to.
Yeah.
Maybe cooperative learning between the two.
Yeah, I was because the way we frame the problem is that basically we consider that searching through an external database induces additional costs. So we want to take that into consideration, but also hallucinations also induces the cost because we don't want the model to hallucinate. Maybe framing the problem this way, a natural solution would be to use reinforcement learning, where we want to see if we want to minimize the number of API calls while maintaining high correctness. So maybe we could design a solution based on this. Yeah. I don't know.
Okay. Thank you very much for your answer. Thanks for all this great work. So congratulations about the floor. Thank you very much.
Merci beaucoup, Linda. Maintenant, on va passer la parole à Alexandre Lejean, qui est professeur à l'USPCI, et qui est l'autre rapporteur.
So first I want to thank your supervisor for the invitation and giving me the opportunity to review the report. In fact, I'm not very familiar with information tables. In the past, I learned a lot of things. Especially this problematic of query documents and query applications, it was very interesting. On the report, I found the report was written and it's easy to read. But yeah, I just want to highlight the fact that in all your work and results, I think that you have to do a lot of experiments, and it was I think not so easy because you use a lot of tools, models, and these models you know that it's not easy to fine-tune this kind of things and so on. So I have some questions. Maybe the first on the first part of your experiment on query clarification and I think in your report at some point you investigate how the beam size when you generate the clarification, let's say, has a great impact on the expected performance or it's a kind of oracle experiment, if I remember correctly. And so the diversity of the generated queries by the model are very important.
Yeah.
So, so it's true that in I don't remember exactly, I think it's in chapter 4, it's not clear whether in fact this diversity is really taken into account in your experiments. So do you measure that? This is another question.
Okay, so chapter 4, so it's about the augmenting.
Yeah, it's the first set of experiments. Maybe you have a table, I think it's, yeah, before.
Before?
Well, before. Yeah,
Pardon.
Juste après, voilà, this one. So just before this table in your report, we did the experiments on the research.
Yeah.
And so here, in fact, again, I didn't understand what was the conclusion for generate, for instance, this table and these results.
Okay, so first of all, we wanted to make sure that our model that generated the set of queries was actually able to generate a set of queries among the generated in the generated set that was better than the original query, because there is a chance that we can generate a large set of queries, but they are less efficient than the original query. So that's what we measured, yes. So we basically we used beam search to generate a set of queries, and we increased the size of the sets, and we measured how it impacted the maximum performance of the set. So how well the best reformulation generated performed. And I think when we tested up to 64 in the experiments, so we have a large set of queries of 64. And that's what we used in the experiment after.
Okay.
And in the experiment, we also tested with the diversity beam search. So it's a parameter that makes sure that across the different beams, we have a diversity of tokens that are selected. And that was really crucial about the maximum performance in the set. Because if you only rely on beam search, it's basically always our model was generating very similar queries, so we constrained it to generate a set that was containing diverse queries using the diverse beam search.
Was exactly my question. And then on this table, so as I said, I'm not familiar with this domain, so for me, I see a lot of numbers. They are quite nice. But at the end, I don't understand exactly.
Okay.
Let's say when the differences are really significant, and so the question, one of your claims is that if you increase the number of terms, it's better for the results. And for me, when I look at this table, it's not clear.
Okay, it's better in the. We only measure the score of the ranking, so we don't consider the user. So this table, yes, it's better because it retrieves more relevant documents, but on the other end, we have to make like a few turns to improve. Yeah, not so much. The user is maybe not willing to spend 5 interactions with the system to have very few differences in the ranking. Yeah, so.
And that's why also in the line, for instance, you have some score decrease while you increase the number of turns, we expect that they increase, for instance, in your data, for instance. For turns 3 and 4, won't increase the score.
If we look at the user query, for example, so without interaction, additional interaction with the system, it has MLF, which is basically indicating how high in the ranking the first relevant document is. It's 0.45, and if you look at our model, it starts without interaction, so it's at 0.4. So it means that it took the pool of queries, it's estimated performance score in the queries, and the best query according to the model was performing worse than the original query. So we can see that. Okay, so it's not useful, but because as I said earlier, it's a really difficult task for the system to evaluate. Okay, is this query better than this one? Given that we have very few context, we only have to rely on the user query. So if we contextualize with this, using what can I do to improve my thesis, it's really difficult to estimate, for example, Q4 is better than Q5. We don't know, we have to interact with the user to understand that. And this is why it's important to see that with one interaction, we manage, for example, with the canon to unlocking the user query, but also the notify which is basically a strong model, pre-ranking model, but with few contexts, it cannot excel in this task.
Okay. Maybe I have so in the next set of experiments, we try to do reinforcement learning to say that to fine tune the model and language model to have more diversity in generation of the suggestions.
Yeah.
And so you use proximal PPO1.
Yeah.
And I wonder if at the end you really evaluate the real diversity of the suggestion and how does it work in fact?
Okay.
Or how does it perform?
So the first one, we use the diverse beam search, but it generates diversity in the selection of tokens. Here we wanted to have diversity on the rankings. So we wanted to see the different ranking across different generated queries, and we wanted to see, okay, these queries, the AI is quite similar if you look at the other words, but it leads to very different rankings, and that was the main metrics we wanted to see and to improve on is the diversity on document ranking, and we use this measure to we try to improve the generation of queries based on the.
And my question was more on, say,
Okay.
is it you need a lot of data to fine tune this model with CPU and to have a nice result, for instance? What is the amount of time you need to really improve the ranking in this case?
It's a good question. We performed experiments on Erbacher, which contained it's a large collection of documents and queries. So there was no issue on that. I mean, the model was first fine-tuned to complete a set of queries. So I think between the fine-tuned model and the model with reinforcement learning, there was only a few, the difference in parameters is very small gap. So I don't exactly remember, but I don't think there was a large need for large.
Do you think it's well suited for fine-tuning a small amount of data? For instance, if you want to specialize at some point with respect to a user or a group of users, it could be a nice strategy to do that.
Well, I don't know, because if you want to adapt to users, you need annotated data. So here the data is generated by the retriever. Basically, for given a generated query, we retrieve documents, and then across all the queries, we estimate the diversity score. But yeah, to adapt on users, it's different because you have to adapt to what the user wants.
Maybe on the last set of experiments, so when you want to learn, say, one that the LLM can learn the fact that you should rely on an external, and you should do a query on the database instead of answering some hallucination. At some point, we talked about naturalness. Can you evaluate the naturalness?
Okay. This one?
Yes.
Okay.
And my question is very naive, but is it important to have naturalness in this case for the user? Is the critical feature that you want?
Yeah, but
it's nice, but in terms of efficiency,
okay, so we could. The goal here is to have a natural conversation with the user. So naturalness, I think it's important. Otherwise, we could just suggest a set of queries, for example, 2010 and different dates and just consecutive wins. And so the interaction is not natural because in the end, the user evaluates all these clarifying panels and must select. Whereas here it's a natural question that could be asked, for example, in the voice-only interactions. If you, I don't know, if you talk to Alexa or Siri and you don't have any visual information, so to interact with the user, you prefer to use natural language. I think in this context makes more sense.
And maybe a last question, during these experiments, last set of experiments, you compare what you obtain with respect to a baseline, and the baseline is based on perplexity and threshold. And once again, the main question, is the perplexity threshold, say, a good criterion for good evaluation criterion or good decision criterion?
Okay,
let's say differently, is it a very weak baseline or not?
So there are various works, so like the project and the second one that compare their model with the perplexity threshold, and they show that it's still a strong baseline in the sense that the likelihood is a good proxy of whether or not the model is confident about the answer. It makes sense because for a language model, if you ask, it depends on the training data. So during the pre-training, it has a lot of documents, and if across all the documents, the information was consistent. For example, that the capital of France is Paris. Then when you want to generate an answer, there's probably, in the distribution, there's probably like a Dirac on Paris, if you ask what is the capital of France. Whereas if the information is more diverse, in the sense that across documents during the training, there was other token in the context, like I don't have any example of mine, but if there are, for example, if we look at ambiguous questions, in a lot of documents, the model can see that for the question, when did the first generation of human appear, there are multiple answers, so it can be seen by the model during the pre-training. And when you want to, when you ask the model in France, it's more probable that the probability is more flat on multiple answers. So yes, so the likelihood I think is still a good proxy. But yeah, there are other methods. I think I have slides in the end, such as okay, there are masks, but there are basically one method where so still in this framework. Sorry for. So still in the first framework, when they probe the language model, so with questions, the model answers, and then they gave the question answers paired to the same model, and they asked to predict whether or not it is true. And what they found is that the model is mostly able to estimate its own knowledge. There's also another method, which is a cross-entropy, which is invariant to the phrasing of the answer. So, for example, I gave the example of what is the capital of France. The possible answer, correct answer, could be just Paris, or it could be it's Paris. And if we only look at the perplexity, we obtain different scores. But they propose a new way to compute. So basically, what we did is that they compute NLP score on the answer that are similar, and this is their new metrics.
Thank you. Maybe a last comment. I forgot to mention that in the beginning. Also, really enjoyed your presentation. It was nice, and it's a nice compliment to your work. So very interesting, and thank you for doing that.
Merci Alexandre. Je vais maintenant céder la parole pour un moment à Mohamed Chadi, j'espère que je l'ai bien prononcé, qui est with assistant professor at the University of Amsterdam, and you can ask as many questions as you like, but you know the price.
Thank you. Pierre, thank you very much for the presentation, especially doing it in English. So I really enjoyed the thesis itself. I think it's very well written, very important problem that you tackled. And I see the evolution of the thesis is very interesting, starting with the clarifying questions, but then ending with LLMs and trying to address hallucination. I think this also shows the impact of the big changes that happened during your PhD. Which is great. I think also shows your creativity and also the ability to the flexibility that you have. Oh, that's better. Okay. So yeah, I think yeah, as others said, I think you should be proud, and it's a great piece of work. I do have a few questions about different parts. Try not to go 1 hour, but let's see. So I would also like to start from the first part of your thesis. So you mentioned that you use diverse beam search to have a diverse set of query formulations, which makes sense. But what is not clear to me is that how do you guarantee that these diversified query formulations would indeed address different facets of the topic, or is it an assumption, or is it something that you check and you control in your mind?
So it was mainly an assumption, and so that's why we generated a large set of queries. It was trying to cover a maximum number of facets given the queries. Did not check. We could have checked with a data set that has many facets annotated given a query. Yeah, that's a very good point.
All right, thanks. And one thing that I noticed in this work is that you assume that all queries that are in the dataset require clarification. And what if the query is already clear enough? Do you still think that these reformulations would be useful, or would they be extra headache for the user?
Yeah, that's a good question. Yeah, the main problem is that we tend to, when we look at the results, it's over a large set of test queries. So and we usually look at the mean results across this query. So when we say, okay, our metric is we have better performance on these metrics across the set, we are happy, but yeah, I see what you mean in the sense that we should consider query individually in the sense that they are maybe clear and they don't need reformulation. And this is where I think the user simulation should play a very important role.
And then you heard the signals, for example, from these reformulations. Let's say if they are very similar to each other, maybe that's already a signal that the code is specifically now.
Yeah, but that's tricky because we use diverse beam search, we don't really we can't look at the diversity within the set because the model is forced to generate queries that are dissimilar. So maybe just the queries are not related to the topic or
yeah. Thank you. Later in slide 25, the next slide, you mentioned that you use MSMart as your data set. So what we know that there is in the training and development set of MSMart, we only have one relevant document or passage per query. So I was wondering if you are targeting different aspects, different facets of the query, but you only have one relevant document. How do you ensure that this, like in your experimental setup, you are capturing multiple like interests or user information needs on different facets of the same query?
So in MSMart code, there's only one relevant document annotated for each query, but the main assumption we made is that the original user query is not perfect. So the goal was just to help the user refine its query by suggesting a set of query suggestions. We did not investigate how we can cover various facets. So, yeah.
So it's
However, in the test sets, there are multiple, it's just in the training set. In the test set, there are multiple documents annotated from query. So that's why we tested, we tested both on the subset of the dataset, which contain one relevant judgment, and also on the real test set, which contain much less annotated queries.
Yeah.
I think it's around 50, but has much more annotation. So, yeah.
All right, thank you. So on the results table in the next slide, also going back to some,
Sorry.
yeah. Also going back to some of Alexandre's comments, one thing that struck me was the fact that user query with no interaction is much better than, for example, the models that you propose here, also in the no interaction setup. So I was wondering, why did you not start a conversation or your retrieval with just using the original query, the user query, as your first interaction? So then in that column, everything would be 0.45 for MRR. Why did you choose not to use it and instead go for the next most relevant or most similar query formulation in this case?
Because the goal was really to, in preliminary experiments, we showed in the paper that we can generate sets that contains reformulation that are better, but that contain that we can generate a set of queries, and at least one of the queries performs much better than the original queries. And the goal was to basically try to re-rank this set, and we tested, okay, without any interaction, how well can the model perform? Okay, it performed very poorly. But what if we add one interaction with the user? Okay, it's much better now. Okay, it's really dependent of the selection mechanism, but we can see that just one interaction we can already do better than the original query. And then as we increase the number of interaction, also, but yeah, we wanted just to see how additional interaction with the user selection help in. So I'm not sure if I.
No, I think that makes sense. Thanks. And that also relates to my next question. So as we see here, if you, for example, look at the random sampling, it means that if you, so in a real scenario, you could say that any system could generate some query formulations and just randomly pick one, add it to the pipeline, and then it's somehow guaranteed that the performance would be better. Is this something you would say or would conclude from this experiment here?
It's difficult to answer to this one. Yeah, it's not random queries in the sense that they are generated by a language model that was given the original query. So all the generated queries in the set are really close to the original query, just that the wording is different, or they are targeting different subtopic or facets.
Yeah. I think in a sense it could be related to, for example, old IR models like RL3, where you have pseudo-relevance feedback. You could also say that we could use LLMs for like explaining better the query or reformulating in a better way that the system understands. And then it's good enough so that any random sample from it could help the system, right?
Yeah, with the assumption that the user is fully cooperative, because otherwise it could give a wrong direction, not the search direction. All these experiments, the user simulation is fully cooperative, so we can fully rely on what the user what the fuck. We can fully rely on the feedback, which is not the case in the
real world, yes. Yeah, I know.
So maybe the random sampling is not efficient at all in the other setting. We did not test
Yeah, because you have a cooperative user, so
Yeah.
it corrects it. That makes sense.
It gives at least a direction.
Yeah. All right, that's clear. Thanks. And again, I also have a question about the terms 3 and 4 here. We see a drop in performance in most models. Does it already tell us something that maybe 3 interactions is already more than enough here?
Yeah, probably. So this is the results from the test set. So they are very. So there is a small number of queries. So one hypothesis is that there's a strong variability because of we evaluated a small number of queries because we don't observe this pattern in the when we evaluate on the dataset. It contains, I think, on the subset of the dataset, which is containing 1,000 queries, I think. So maybe, for example, it's clear for the canine. We see after between the second and the third term, the performance it doesn't improve that
Yeah,
much.
it's already saturated.
Yeah.
So a bit of a technical question here regarding the k-means model. In the report, you mentioned that you use k-means to break down the candidates into 2 groups. How did you come up with the number of 2 here? And did you test it with other, like, larger number of groups?
We tested 2 because we in the interaction we fixed the number of suggested queries to 2, so it was natural to set the number of clusters to 2 also. But yeah, I don't know. The goal was to give different ranking in the clusters to queries, and then select each time the best query from the different cluster. The goal here was to ensure diversity in the suggested queries. So we don't want to have the two queries suggested to the user that are too similar, because it provides almost no information.
All right, well, thanks a lot. And my last question about this part of the thesis is more like a general question. So you've been working on selecting and generating type questions for a few years in your PhD, and we still have this fundamental question that is how can we define, how can we say a critical question is a good one, a high quality one, compared to the other one? Do you have any thoughts on this?
Okay, very good question. So if I look at this slide, so in the end, the goal is to generate an answer, and the answer must be accurate to the user. The answer needs to be aligned with what the user wants, and for this, the system it can I'm searching my words, sorry.
Yes. Okay.
So the systems need additional information to make sure that the answer is correct. So it can either ask information to the search engine, but also to API calls, but also to users, in the sense that the question is used by the system to retrieve information from the user, so retrieve information from the real user's name. And we can see this as how much gain in information can we have through one of the questions. So
you would say we look at the system side, like how much additional.
how much additional information the systems gain with that questions. But for example, single facet client questions are terrible in the sense that you make one interaction turn with user to just to just have a confirmation or check that this is the good subject.
Yeah.
But it's costly on the user side. It's costly to answer questions. So maybe there are different things to take to consider. So first is the amount of information we can gain from the system side, but also the cognitive load on the user side. So there might be a trade-off here, depending on the user.
All right, thank you. I think it's a very nice perspective, and I agree with it. Although it's again hard to measure and also control, yeah, I think that's the way we should go. So if we move forward to slide 28. So I have two small questions here, hopefully small. So how do you control users' cooperativeness in these experiments? This is also something we discussed yesterday. It's not always the case that we can easily control this. And so I was wondering, how do you do this? And yeah, maybe I can ask the next question after this one.
Okay, for the cooperativeness, we use epsilon really user simulation. So epsilon really is just you see on the left of the bitmap, there's the epsilon. So it's a value between 0 and 0.5. So at each turn in the clarification process, the user has a probability of for example, 0.5 to not be fully cooperative. In the sense that given the interaction, it will select something at random. And so yes, when epsilon is at 0, the user is fully cooperative. So it always provides good feedback.
Okay, thanks for that. And I was wondering in your simulation, in your current training, so do you also penalize so we know from the literature that if you ask a bad question, clarifying question, it has a lot of negative effect on the user experience. Do you consider this in your interaction models, like by penalizing a bad question, or is it only based on the reward that you give only to good questions?
Okay, in the reinforcement learning, the reward is only to improve the diversity of retrieved documents. And so I think you mentioned is the generated queries in the set efficient. Yeah, can you rephrase the?
Yeah, sure. So I'm mainly wondering, like, if the generated reformulation is irrelevant to the user's information need, is there any penalty for that?
Okay. So the model was fine-tuned to generate queries. So it's similar than what we did in the first work with the beam search. We want to generate a set of queries. So these are queries that are very similar to the original query. And the main penalty here is that for the PPO training, we basically have a frozen model. So we fine-tune the model on this task. Then we froze one person the model. And we have the another version that we update with reinforcement learning, and we make sure that the model we update is not too far away from the fine-tuned model. So using a care divergent penalty. Yeah.
All right.
So because using only reinforcement learning on the model, we could diverge and generate queries that are very far from what we would do.
Exactly. Also, this is probably related. I was wondering here, you mentioned RVO. I think this is like your reward function in this case. Is that correct? So with RVO, you could get very diverse set of results, right? That results very different from two, if you compare two ranked lists, with no guarantee of their effectiveness. So you could get, for example, 10 irrelevant documents, but very diverse.
Yeah.
Do you control for that in any sense, or is it just a kind of pale evidence that you think still controls that?
Yeah, I totally agree. I wanted to add also in the reward something that judge the ranking based on the relevant judgment. And we first tried with the MRM metric, but it gave very inconsistent results, and the training was really, really difficult because the problem with the MRM metric, for example, is that when relevant documents are at the top of the ranking, you have an MRM of 1, which is the max. But if it's at the second place, it's only 0.5. You divide each time by 2. So it's a longer, it decreases exponentially, I would say. So this means that documents that are retrieved but at the 10th position have very, very low reward that are maybe similar, mostly similar than ranking where there are no retrieved relevant documents. So we removed the MRM metric from the reward, but afterward I was, okay, maybe we should have used a cross-encoder directly that measures the similarity between the query in the set and the relevant documents in the MS Markup, because the score is normalized between 0 and 1. Maybe that was maybe for the training with the smoother reward that would have been better.
Yeah, I understand. Yeah, that makes sense. Also, I agree. I think MRR could really penalize too harshly the rank list. Yeah, thanks a lot. So I want to skip a few of these questions they already asked. Can you jump to slide 37? Oh yeah, here. And so it's again a more general question. I assume that you develop these models in the pre-ChatGPT era. Yeah. So it seems to be that a lot of these innovations that you had here could now be just replaced by some prompt engineering.
Yeah, sure.
And what's your take on that? How would you redesign these pipelines and these models if you were to do it today?
Yeah, okay. So basically, I think here we try to take higher documents and increase augments with so clarifying questions and answer. So, but the naturalness is not really a point. I think I would take the problem the other way. So I would first generate natural search-oriented conversations where the user may ask for various facets in the same conversation and so on. So have something really more natural, and then augment it with pseudo-relevant feedback. Or I think I would try the other way with ChatGPT model. Yeah.
Okay, thanks. And on slide 40, so also related to what we've seen in the previous part of the thesis, you always go interactions up to 5. Right? So you assume probably that this is the maximum number of terms that the conversation or the maximum number of interactions we could have with the user. So, so my question here is that, do you think that this is realistic? Like, can you expect users to interact with the system 5 terms? And where would be the balance? Like, how would you say if you were to deploy the system in a real world case? Where would you really stop? Decide, okay, I've asked enough. Let's just stop here. Show some results to the user.
Yeah, it's connected to your question about what are good and bad clarifying questions, in the sense that if the system evaluates that the next clarifying question may not increase that much the ranking of documents, maybe just skip it. So it's also connected to the detection of ambiguity behind queries. So that's why we wanted, after this work, we wanted to work on the ambiguity detection, because yes, sometimes some queries don't need a clarification. So I think no, it's not a realistic setting, in a sense that given for one information, some user may not, depend on the user, but some user may want to interact only one time with the machine, and some may want to spend more there. But I think, yeah, that the main drawback of this work is that we don't evaluate when to stop. We just evaluate what's the gain in terms of effectiveness, ranking effectiveness.
Yeah, I won't cover the drawback, but this is like an assumption that we make here. And yeah, that's another problem to solve maybe in the future work. And then I have one last question about this part. Again, a little bit of philosophical. I'm asking some of the questions that I've always had about clarifying questions, and I want to know your perspective on them. Let's say in most experimental scenarios, we assume that the user knows what they are looking for. Right? So it's more or less saying that the user is too lazy or too doesn't know much about the capabilities of the system, therefore the queries are like vague or incomplete. What if the user asks a question, like in the example that we show in the next slide, and that comes from the fact that they probably don't know much about the domain. For example, I might not know that we have a lot of Batman movies, so I just asked this question. So instead of the system asking me which Batman movie are you referring to, which would confuse me even more, it could give me some background, like, you know, there has been these Batman movies over these years, blah, 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 and then which one do you think are you referring to, or can I help you find some? So maybe and then in that respect, what is your take? What is your opinion? Like, how can we improve interactive systems where we lift this assumption, right? So we also assume that the user might not fully know about the topic that they are trying to explore.
Okay, so there are two parts in the answer. So the first one is about personalization. So, for example, something an engineer working in a very specific field, we assume that he knows its domain. So when he's searching for information, we can make some assumptions and maybe interact more directly with him. Okay, the other part of the answer is that the system are supposed to summarize retrieve documents or retrieve answer across documents. And yes, if we want the system to help the user navigate naturally online, we maybe yes, first have to expose what documents have been retrieved and why is there confusion with the an ambiguity in the query. Yeah.
So in a sense, from what I understand from your answer is that if we try to explain why something is ambiguous, maybe we are already giving some extra knowledge to the user.
Yeah.
Is that correct?
And maybe yes, it could help the user refine its query.
Yeah, I think that makes a lot of sense. Thank you. So I don't have much of many questions in the next part, so we won't go to 1 hour. Slide 48, you mentioned hallucination. What I didn't understand from the report and from the presentation is that how do you actually quantify hallucination here? How do you determine something is hallucinated and to what extent?
Okay, for this we rely on the question answering datasets, so that are given field and natural questions pre-actual. These datasets are contain questions and also annotated labeled answers. So for natural question, I think it's for a pair, so it's one question and one answer. In pre-actual, there's a set provided of the answers or possible answers. So sometimes just the same answer but written differently and so on. And we, like all question answering benchmark, we do exact match. So between the prediction and the answer. So we take the generated answer, we normalize it in so that we remove yeah, I forgot the name. Yeah, because in trivial QA, for example, the answers are what they call normalized. So there's only a certain number of characters that are low, so no uppercase and things like that. So, and then we just look at, okay, is the predicted answer in the set of level answer.
So if I understand correctly, you look at the correct answer, and if the generated answer does not match the correct answer, you assume it's hallucinated. Is that the way you do it?
Yeah, that's why in the end we consider that this method is noisy, and in a lot of questions in the literature, people are aware of this problem in the sense that between the automatic metric, which is exact match, and the real performance of the model, there is a gap because for example, if we look at natural question, we saw earlier that questions are actually ambiguous and can have multiple answers. However, in the original data set, there is only one possible answer. This means that even if the model predicts a possible correct answer, but if it's not in the test set, it will be considered as a wrong answer.
Thank you. And slide 52. So I'm gonna wear my IR glasses here. And you mentioned, my question is that how do you think we could use IR signals to improve LLM performance here? Like, for example, you mentioned that we first, if I remember correctly, we first generate the answer and then evaluate if this is correct or not, and then based on that, or if we ask the other agent to evaluate the answer, and if the other agent thinks it's incorrect, then we, for example, call a tool or call a search engine. What if, like, we try to make it more IR-ish? Let's say we use query performance prediction, or we look at the rank list of results, and then do you think that there is any signals that we could use there to kind of improve this pipeline?
Okay. So maybe you are referring to the probability of getting a correct answer by searching through the class. In this work, we only stop at generating search token, but yeah, it could be interesting to see if actually searching will help the model generate, and if it's retrieve a relevant document first, and if the retrieve document help generate a correct answer. Yeah, that could be a strong signal from the retrieve document.
Okay, thank you very much. That's all my questions. Thank you.
Merci, thank you. And I will now give the floor to Pierre, who was our PhD director. Pierre, so if you want to say a few words. Less than 1 hour.
Okay. First, I would like to thank Julie for being here today and also taking the time to accept the Pierre Awards in this kind of discussion. And also think for Sophie, which is not able to join us today, but that will tell us what we think about her. Just to give a context about this thesis, this is the thesis for me in the context of INF research project on conversational search. And when Pierre started 3 years ago, the research field was quite new, with no data sets, no need to train and evaluate models, and it was quite a desert, and we had a long discussion about this and how to start to work on this field and how to deal with that. And I know it was political and also sometimes it was difficult, but finally we achieved to do something, and I believe in that. So Pierre was chosen to focus on simulation first. For that, there's a motivation to integrate reinforcement learning within models. And finally, we achieved to do something in terms of the proposition of dataset generation and the introduction notes. I'm very appreciative to work with you, Pierre, on this topic. We had a lot of discussion and also long brainstorming session. Sometimes we need to clarify the storytelling about the work, but I would like also to mention that the evaluation were properly done, even if sometimes the storytelling was not quite clear, but I can identify quickly that you have very good ideas in terms of contribution, and also you are able to design quick proof of concept to test your ideas, and then we have to work again to defend this contribution, but it was a very good starting point. Also, Alexandre mentioned the tools, and this is quite also an important point of this thesis. I can say that ICU has a kind of library of LLMs. You have in mind quite a lot of tools, the metric you can use to evaluate, and also a lot of papers. And for the last month, during other meeting with other students, open, I said, as Pierre, so for me, this is kind of good that you have a good knowledge about that. And also we were able to collaborate with other PhD students and also with the researchers, so that's a good point for the thesis also. So thanks a lot for these 3 years. We have still a few months to work together to wrap up everything and maybe pursue some work, and wish you all the best for the future. Thanks again.
Thank you very much.
Merci, c'est gentil mot. So it's my turn to ask a few clarification questions. Okay. So first of all, first of all, I would like to congratulate you on your final presentation. I think it was a very well did and organized and structured, and it's a nice complement to the report.
I also read the report and I learned a lot about AI research. I don't know so much. And as I am not so much in this field, I was a bit surprised because I didn't appreciate the gap between like the group research question you ask about like reading users and having conversation with the user, which are somewhat in abstract. And then you have to implement experiments, and then you have to make concrete choice about how do I simulate this user, what kind of AI model do I use, and what is the collection behind this. And all this has consequences on the results. So for me, it was a bit of a surprise, and this will maybe explain some of my questions because I was like, as I said, puzzled sometimes by the choices you've made, and maybe we can discuss them. And to illustrate my puzzlement, I will start with a table that is not on your slides. I didn't maybe you have a backup slides. And it's a table that is on page, I think, 73 in your manuscript. And I mean, I can, you don't have to go to your manuscript, but basically, it's a table where you give illustration of clarifying questions. And what I see is that, I mean, most of the time, clarifying question is adding more words to the query, like is extending the queries with probably facets of the query. So this raises two questions. I mean, if clarifying questions are always like augmenting an existing query, so maybe you could use this in your model because I don't see that assumption is anywhere in your model. So it seems like you generate queries from scratch every time, even though it's conditioned on the formal query. You don't assume that you will just need to add a few words to it. So maybe it could help, or maybe it could not help. So that was my first question, maybe a technical one. I mean, is it reasonable to make the assumption, and how would you use this in your model? But the second question is also, when we add facets to a query, depending on the model, sometimes it's not clarifying, it's confusing. And I will take my experience, for instance, with Google Scholar, or with my experience as a researcher in machine translation. Many times I ask for like a technical term, okay, and then if I add translation, so I want this technical term in translation, but the system behind it takes translation as a main query, and then it will present me with long pages of translation of this term, which is not at all what I like. You know, so in fact, the way we rephrase the query, in fact, should depend on the IR model that is interpreting it, because we don't know exactly what the IR model is. I mean, you can involve those, but sometimes it's not, you know, it's not clarifying, it's like confusing in that sense. So these are in fact the questions.
Okay. So I'm not sure what
the first question was, is clarifying, I mean, as it's in chapter 5, just adding more words to a query, more facets. And if so, couldn't you use this fact, like to either simplify your model or to like train it in another way? So that I mean, maybe it's not what you observe, I mean, but I just have this small set of examples on paper I'm going to use, where most of the clarifying queries are like adding more words.
Okay, so clarifying question is not just about adding new words to the original query, because sometimes the original query contains a word that does not match the true information need. So because I don't know, the user is not an expert in the domain, so should this word that are suboptimal or not really relevant. And so in the first work, we reformulate queries. And so I don't think this is...
Yeah, but I mean, the example you gave, you know, this, okay, maybe this is a Google way, but I think they're thought of the way to do this. And the example you gave are only about adding more words. So I'm sure that I mean, when you regenerate words, when you regenerate queries, you can have a lot of more diversity. But I mean, I was puzzled by the fact that, I mean, the examples that were given were really about adding new words.
Yeah, there are different strategies to generate suggestions. So I think talked about this here. Okay, it's really small. On the figure on the right, you have the query completion, where you add new words to the original queries. And a query refinement on the other end, you rewrite the query, given possible topics that the query could be that could match the user. So I don't think query. Maybe in the example here, I showed an example of query completion, but I don't think clarifying the query is just adding new words to the original query.
Well, I mean, I guess that you work on your own model because I mean, the color is labels simple form, so maybe that was a system.
Oh, okay.
But maybe, I mean, it's a poor example of what it actually does, and the diversity of the generated is much more, it's much larger than this. But I mean, I was, just wondering, looking at these examples, what your system is actually producing.
Okay, okay, I think you were talking about the second word.
Yeah, it's in the chapter.
Okay, so is there a question? Okay.
And for the other question? So, I mean, the way you can, like, generate new queries without knowing exactly what the AI system will do with new generated terms. I mean, is it a reasonable assumption? I mean, even a reasonable way to look at the problem? I mean, I think that in chapter 7, you do differently. Simulate a query, you look at the ambiguity, so you look really at the collection, and then you decide whether there is an ambiguity and whether you need to clarify. But I mean, in the first part, you don't do this. It's a clarification without questioning the collection itself, which can be large or small or ambiguous or non-ambiguous, can contain diversity of documents. And I was questioning this aspect.
We took a little shortcut for this, yes, in the sense that maybe the model generates queries that are not really relevant regarding the collection of documents. But we made the assumption that the language model has, during the pre-training, seen a lot of documents. It's not correlated with the collection we tested on. But for example, the Google suggestions are not related to the MS Marco collection also, but they show strong performance in the sense that query suggestions from Google are probably constructed from large from logs of users, sorry. From lots of user reformulations, where they first input the first query and then they reformulate into another one. So the most probable reformulation are proposed in the. So I don't know. Maybe maybe could be wiser to first look at the collection and evaluate what kind of query you want to suggest could be.
Not only the collection, also the way the IR uses your query to formulate, to search.
Yeah, but it depends on the collection. So.
Yeah, sure. So, I mean, that was, my first sort of puzzlement about the way you organize or define a problem. I must say that I liked chapter 7 more, somewhat, so I will skip chapter 6 for the sake of time, for various reasons. One of them is because I like clarifying questions, and I know being a big fan of the Monty Python, that clarifying questions can save your life, actually, so I think it's something we should look at seriously. And I want to start with the slide 37 or 38 maybe.
This one? 37?
38.
38.
Yeah, I would like to know your what we can say about this accuracy of 0.65. So it means that when you generate or you simulate the user answer, you're wrong about 1/3 of the time. Is that the way you should?
Yeah, the thing is that the generated clarifying question were, as I mentioned, really independent of the extracted keywords from the passage, and sometimes there's keywords that are extracted that are not really reflecting what the passage is talking about, and that leads to very to Python questions that are not related to the query. So it's for evaluator, it's an in between. They are faced with a clarifying question that should be, for example, answered yes, but because it's like less natural, or because the query is extracted, does not reflect well the passage, they answer no in 1/3 of the time.
So what is the impact of this? I mean, would it be better if would you get better performance if your system would reach like the 80s for this score? How does it matter on your system? What are your conclusions of this? I mean, it's a bit surprising.
It's additional noise in the training set. So when we train on this,
you can go next slide.
Okay.
I mean, it's a user slide.
Later, we train the ranking model on users' answer and clarifying question, but also we also train the user simulation to answer these questions. And if they are, they are not correlated fully with the human judgment. So this means that if we only rely on the user simulation, okay, it's help to increase the overall performance. But if we now move to real user with the same system, maybe the performance, there will be a large gap in performance between the user simulation. Yeah.
Yeah, okay, and then, I mean, maybe it's also a clarification question. What is the exact way you use this system in inference? I wasn't really sure that I got it.
Okay, so given query from the Sparkle dataset,
Yes.
we first retrieve passages, and then we consider the top of retrieved passage to generate a facet. We extract the facet from the top retrieved passage, because according to the ranker, it's the most relevant passage. So we want to ask the user if this is the subject he wants to if this is
sorry, I think that I got that part right. So this part is about generating like simulation, right?
Yeah.
So you generate questions and you simulate an answer, and then you will use this to train a system that can generate good clarifying questions.
No. So basically, we augment offline the original dataset with clarifying question answers, and then basically we get a part of the datasets to train the ranking model, and the other part to train the user simulation.
Okay.
And then at inference time, so this is we here in the online generation we use the user simulation to answer yes or no. And for the model that runs passages, it's we evaluated during the IR task. So
Okay. Another question, maybe a more general one that I have, but it's already been asked, is about, it again relates on the abstract user you're trying to stimulate. It's not clear to me, especially, I think, in the example of slide 44.
Yes, I mean, it's not clear to me whether I would like to have directly I mean, on small collection, for instance, I mean, you're right, the system is in between the user and the collection, and it's performing requests to the queries to the collection, okay, getting answers, and still hiding these answers, and using the answers to ask questions to the user, instead of like directly showing him or she the results on the list, or maybe there are many ways you can display these results on the screen, assuming you have a screen. Of course, the other context, I think you have answered all these questions to Alex, is to say this happens on the phone, or this happens with without screens, and then it's legit to ask oneself the question how to formulate this. But I was curious to hear a conversation about this. I mean, when is it like more efficient to like reformulate rather than so how many I mean, what is the degree of ambiguity you would consider acceptable to display a user instead of like reformulating? Because I mean, the user doesn't know exactly why you're reformulating this way, because it doesn't have access to the collection. So now the system is like hiding the information that is available after the first retrieval. And I was wondering, I mean, what is the right, how you see the right balance between like having a conversation versus like try to find a way to display this results to the system to be with that direction.
Okay, so it maybe not clear here because there are only, for example, 3 different interpretations. But in the for example, when you want to when the query is ambiguous and you don't know what the user is talking about, because there are like 1,000 retrieved documents and 100 different facets, even displaying all this result to the user is really. If you expect the user to select and filter all these documents by estimating their relevance for given his information, it's really time consuming for the user and cognitively demanding also. So it's better to have a system that from retrieved document, the 1,000 first retrieved document, for example, that can summarize what are the different ambiguity, I would say, around the query is beneficial in a sense. I'm not sure if
no, I'm sure there are contexts where reformulating is better than displaying a very long results. I wanted to know, I mean, the kind of trade-off you see in this task. I mean, because I mean, you can agree that I mean, if the ambiguity is very low, I mean, it's easier to display the results directly to the user rather than having to go into an extra round of query.
Yeah, that's what we discussed earlier with the trade-off between the gaining information with a client function, with an additional interaction terms, and also the user's engagement in the conversation. In the sense that yes, some users prefer to have all the documents run and don't want to engage in the conversation with the system, and also maybe willing to have various interaction with the system before. Yeah, in the sense that the more clarified the query is, the more specific the user also the answer is. I don't know.
It's a difficult question to answer in abstract. We need to make more precise assumption regarding the kind of system, and kind of setting, and maybe also the kind of field that you share. And that's the core focus of your knowledge.
But maybe if I can add something,
yeah.
For example, if you query one of the examples, it's not shown here, but it was a very ambiguous question, like what's the last time England played in quarterfinals? So you can have various types of ambiguity around this. So one is around which sport are you talking about? So is it like rugby, tennis, or football, or soccer, whatever? And then it could be also, are you referring to women or men playing it? So here we show only one term in a sense, but we can imagine that in natural conversation, we can, as a user, about this different ambiguity at each turn in the conversation to refine because if you determine that the user is talking about the sport, a specific sport, you can then retrieve new documents to better evaluate, okay, is the query still ambiguous or is there still ambiguity in the new retrieved document? So, and then you can refine as the conversation goes.
I see. Maybe the last one about the last part of your work, and you already had several questions, one by Linda, so by Mohammed about this, but maybe I will find a different angle. So I was curious to see whether it would be possible to somehow merge the work you did on ambiguous questions, at least chapter 7, and also the work you did on chapter 8 on trying to see whether the system can answer directly. Because I mean, as we say, I mean, the answer is not always yes or no. I mean, the question can be vague or as ambiguous. So would it make sense to try to like also add a reformulation procedure, maybe either to the user or visible to the user when you do? I mean, you could say, okay, you can test whether you can answer this question, but you can also test whether you can answer reformulation of this question that you can generate automatically, and then decide whether you will need to call the search or whether the search will be successful. Maybe you can implement this. So would it make sense, or is it something that you have considered, or?
I have not considered it, but it totally makes sense. We know that language models are very sensitive to their input, so the context really is important in the choice of the wording is important for the performance of the model. So maybe reformulation of the question, so some reformulation of the question are able to lead the model to correct answer, while other reformulation may lead the model to incorrect answer. So maybe it could make sense to.
Yeah, I mean, I think it could give you a better estimate of the probability that your model will be correct. Will answer the question by generating a lot of information. And last year, the tools to do this, I mean, I thought it would be like natural to maybe to try this to get a better estimate that you're just looking at performance.
We tried different things. So one possibility was also to generate like 100 answers given the questions and look at the variability in the answers, in the generated answers. If the model always generates the same answers, that the model is pretty certain about the answer. However, if there are the diversity of there's a diversity of answers, then we can conclude that the model cannot answer this question very well. We also tried to put noise in the system, so using the dropout. At the inference time, we started with a very low dropout, and we increased the dropout, so the amount of noise in the system, and we wanted to measure how this additional noise makes the prediction goes wrong at some point. So we wanted to see how much noise makes the uncertainty, makes the prediction flat, I would say.
Okay, and then there are two more comments. I mean, you don't need to answer. One comment is that, I mean, sometimes as a user, I can be happy with ambiguous questions. I can be happy with vague questions. And I just maybe will be surprised with the answers I get. And I will be happy with the answers, even though they are not exactly what I was looking for. And it happens all the time for me when I look at like publication records of somebody. I'm looking for a specific paper, but sometimes I find that the next paper is even more interesting. So So clarifying is not always like, or the exact match is not always correct. But the question I have is how do you see these methods still promising, or the future of these methods with respect to the three-word augmented generation? Because and there is a trade-off, and it's a bit funny to me because it seems like you assume that search is more costly than generation. In fact, it's the other way around. Search is cheap, so we should not worry so much about performing multiple search. We should not worry about generating too much in terms of the actual costs. So why does it matter so much that you can answer with a good search when you can answer better with a very high probability if you do search first?
It's a difficult question. So it depends. Yeah, it depends because actually search can be also costly in the sense that okay, if you consider BM25, it's really cheap, but you can have know-how longer. It depends on the infrastructure and the model deployed behind the search engine. So there are probably language models that generate query reformulation or I don't know. So the main goal of the paper was to say, okay, it was really costly to pre-train the language model on very large corpus, and it's a pity to not rely on what the language model has seen during pre-training and to always rely on the search engine. So we wanted to see if it was possible to balance what the language model already know and yeah, what the search would provide.
Yeah, no, I see this point. I mean, I was curious to hear you about making the link between this and RAG methods that are maybe the future is. Okay, let's close the discussion for now. Thank you very much for these answers. And I think we can wait for the defense and the topic part. So we will now ask the public to retreat someone and carry out this place. So that we can have